Next question, a sample of X liters from a container. A sample of X liters from a container having 60 liters of milk water solution. 60 liters of milk and water solution. 60 liters milk and water solution. A sample of X liters from a container having 60 liters milk and water solution contains milk and water in the ratio 2:3. So a sample of X liters from a container having 6 liters milk and water solution that contains milk and water in ratio 2:3 is replaced with pure milk. So that the container has equal proportion of milk and water. Find the value of X. This question is a bit lengthy and a bit difficult to understand. So what they say is that I have a container. The container has milk water solution. The container has milk and water solution. In this container, the milk and water are in ratio 2:3. In this container, the milk and water are in ratio 2:3. Now they say that a sample of X liters from the container is removed. So they say that the total quantity here is 60 liters. From these 60 liters, they are removing some X liters. Some X liters is removed. So after removing this X liter, what they do is that they add X liters of pure milk. So they remove X liters of this solution and instead of that they will add X liters of pure milk. I already have milk and water in ratio 2:3, which means I had more water compared to the milk. Now after doing this, milk and water ratio becomes 1:1. So this is the question given. Now how to solve this? We'll just see. See here, initially in this 60 liters, milk and water were in ratio 2:3, which means, can I say 2/5? So 2 plus 3 is 5. So 2/5 of 60 is milk and 3/5 of 60 is water. Or in other words, I can say I had 24 liters milk and 36 liters water. Now among these 24 liters milk and 36 liters water, what I do is that I remove X liters of the solution. So if I remove X liters of the solution, again in this X liters I will have milk and water in ratio 2:3. After removing this X liters, what I will be doing is that I will be adding some pure milk. So that again the quantity will become 60 liters. And the milk and water solution will have ratio 1:1. Or in other words, what I do is that I remove X liters totally, and after removing X liters I will add X liters milk. After adding X liters milk, I will have 1:1 ratio, which means 30 liters milk and 30 liters water. I will need to find the value of X. Now if you observe carefully, I am removing X liters of solution. So that solution will have both milk as well as water. But when I am adding milk again, pure milk again, I will not be adding water, which means I will be removing 6 liters of milk, 6 liters of water. I remove 6 liters of water. I will be removing 6 liters of water. If I remove 6 liters of water, I know that milk and water are in ratio 2:3. If I remove 6 liters of water, I will also remove some 4 liters of milk, can I say? So if I remove 10 liters of the solution, I am removing 10 liters of the solution in which the milk is 4 liters and water is 6 liters. So after removing this, I will have 20 liters of milk and 30 liters of water. I remove 10 liters of the solution, now I will add 10 liters pure milk. After adding pure milk, it becomes 30 liters milk and 30 liters water, which means the quantity that I will be removing is 10 liters. So the value of X will be equal to 10 liters. So I will be repeating this again. Here I will be removing some water quantity. Once I remove that water quantity, I will not be adding more water, which means the total quantity of water removed is 6 liters. So if I remove 6 liter water, it means that in that solution the milk and water are in ratio 2:3. So whenever I remove 6 liters water, I will also remove 4 liters milk with it, because the ratio is always a constant, which is 2:3. So I will be removing 10 liters of the solution, and instead of that I will be adding 10 liters of pure milk, so that the ratio will become 1:1. So if I remove 6 liters of water, I will also remove 4 liters of milk. The total solution is 10 liters that I will be removing. In what ratio a person must mix 3 varieties of rice costing rupees 60 per kg, rupees 75 per kg and rupees 100 per kg and rupees 100 per kg to obtain a final variety, a final variety which when sold at rupees 96 per kg, yields a profit of 20%. Now this question, so in this question the mixture contains more than 3 elements. Till now the examples we have seen the mixture with only 2 elements, whereas here there are 3 elements in the mixture. So whenever there are 3 elements in the mixture, the number of ways I can mix them is definitely more than one way. I can mix them in more than one way. So the question here, the answer that I will be giving should depend on the answer options. Reason is, the first variety is 60 rupees, second variety is 75 rupees, third variety is 100 rupees. First variety is 60 rupees, second variety is 75 rupees and third variety is 100 rupees. Now if I assume the ratio as 1:2 something, for this I will be getting a different answer. If I assume the ratio as 1:x:2, for this I will be getting a different answer. If I assume question mark is to 1:2, for this I will be getting a different answer. So this way, whenever you have only 2 different elements, then you will have one possible answer. Here you have more than 2 different elements, which means you have more than one possible answer. So here the best method to do is go from the answer options. So for this question, go from the answer options, that will be the best possible method. Now here the options given are 1:2:4, 1:2:4, 3:7:6, 1:4:2, none of these. So these are the answer options given. Now we will come to the final price. The final price is 96 rupees. The final price is 96 rupees with 20% profit. 96 rupees, that is including 20% profit. Now excluding this 20% profit, so if I include 20% profit, I can say that 120% is 96. Then what is the value of 100%? This will be 96 by 120 into 100. 96 divided by 120 into 100, which is nothing but 80 rupees. So actual cost of the final variety is 80 rupees. The actual cost of the final variety is 80 rupees. Now I will be doing alligation method. For 3 elements, the alligation method should be performed a bit differently. So what I will be doing is that I will be finding the difference between 80 and 20, 80 and 60 minus 20. Here the difference is minus 5. Here the difference is 20. Now I will substitute the first answer. 1:2:4, which means the total difference. So when I multiply with this, the total difference I should get is 0. So if it is 1:2:4, so 1 into, so if I consider it as 1:2:4, I will have to consider in the 1 into minus 20. So 1 into minus 20, 2 into minus 5, 4 into 20. So if I'll try to add all these, so I'll be getting minus 20 minus 10, which is minus 30, plus 80, which is 50. This is not equal to 0. So in this method, you should always make sure that when you add everything, it sums up to 0. I'll try the third option now. I cannot try the second option. Reason is 7 5s are 35. 35 means it will not get cancelled anywhere. So I will not try the second option. I will directly try the third option. So 1:4:2. Now I will try. I will try the fourth option. 1:4:2. So I will take one part of the first element, which is 1 into minus 20. Minus 20 plus 4 parts of the second element. So 4 into minus 5. It will be again minus 20 plus 2 parts of the third element, 2 into plus 20, which is 40. So if I add all these, I will get 0 as the sum, which means I should be mixing them in ratio 1:4:2. I should be mixing them in ratio 1:4:2 here. So this way, depending on different answers, so you can always go from the answer options, but if you want to go apart from the answer options, there are other methods also. For example, I can randomly assume any value to the first one and second one, and I'll try to find the ratio of the third one. For example, if I consider the ratio of first and second as 1, let's say 2:8. If I consider the ratio as 2:8, or let's say 3:8. So 3 into minus 20, which is minus 60, plus 8 into minus 5, which is minus 40, plus which number will give me 0. So I know that this unknown number will be equal to minus 60 minus 40, which comes to the next other side will become plus 100. So I know that the product of 20 into this unknown number should be 100. The unknown number should be 5, which means the ratio will be 3:8:5. So 3:8:5 also will give you the exact same answer. Same way, other ratios are also possible. We can consider it as let's say 2:1:1, so 2:4:1. So that way also I can consider. I'll still get the same answer. Or I can say 2:4:3 will also work. 2:4:3 will also work. So this way there are more than one possible answer for alligation on 3 different numbers. Next question. A zookeeper counted the heads of animals. A zookeeper counted the heads of animals in the zoo and found it as 80. When he counted the legs, it was 260. If the zoo had either pigeons or horses, then how many horses are there? So this is a question given. The question is that there is a zoo. In the zoo, the total number of animals is 80. The total number of animals is 80. So I know that in the zoo there are either pigeons or horses. By or here it means that plus, and means multiplication, or is addition. So p plus h, this value is given as 80. I know that every pigeon has got 2 legs. So total number of legs with the pigeon will be 2p plus. Every horse has got 4 legs. So the total number of legs for the horses will be 4h. This sum is given as 260. This sum is given as 260. The question is to find how many horses are there. Question is to find how many horses are there. To find the number of horses, I have to cancel the pigeons. So to cancel the pigeons, I will be multiplying this first equation by 2. So I will be getting 2p plus 2h will be equal to 160. So when I subtract them, I will get 2h is equal to 100. H value will be equal to 100 by 2, which is 50. So the number of horses there is 50. So I will have 50 horses and 30 pigeons. Next question. In a flask of milk, in a flask containing 30 liters milk, 6 liters is removed. 6 liters is removed and replaced with water. If the same process is repeated 2 more times, then what will be the quantity of milk left in the flask? What will be the quantity of milk left in the flask? So what they say here is that I have a flask. In the flask I have 30 liters milk. In the flask I have 30 liters milk. Now what I do is that I remove 6 liters. I remove 6 liters and I replace it with 6 liters of water. 6 liters water, remaining 24 liters milk. Again from this what I do, I will again remove 6 liters. I will again remove 6 liters. So in this 6 liters, I will remove combination of milk as well as water. I will not just remove milk alone or water alone. So 6 liters I will remove and I will replace it with water. So now I will have some quantity of water and some quantity of milk. So first I did it once, after that I will have to do it 2 more times. Again I will remove another 6 liters. After removing another 6 liters, now it will have water and milk. Now it will have water and milk. The question is, how much milk will be left here? How much milk will be left here? So there are more than one method to do this problem. However, if we are directly going with the method of ratios, then this might take some time. So instead of going in the method of ratios, what I can do is that I can go it in terms of percentage. I can go it in terms of percentage, so that this problem will get over very quickly. So initially there is 30 liters. From 30 liters I am removing 6 liters. So every time I am removing 6 liters only. Every time I am removing 6 liters only. That is, among the entire solution in the flask I am removing, every time you see, if I remove 6 liters I will again add 6 liters. I will remove 6 liters, I will again add 6 liters. I will remove 6 liters, I will again add 6 liters. Which means every time before removing, the quantity of the solution in that flask, that is milk and water solution in the flask, will always be 30 liters. So in 30 liters, if I am removing 6 liters, I can tell it as I will be removing 20%. I will be removing 20%. So here what happens is that from 30 liters I will remove 20%. If I remove 20%, 20% of 30 is 6. So after removing 6 liters, I will have 24 liters milk. I will have 24 liters milk, and after 24 liters milk, I will be replacing it with 6 liters water. 6 liters water. Now next what I will be doing, I will again be removing 6 liters, which is nothing but 20%. Again the quantity of milk will be reduced by 20%. Now the quantity of milk is 24%, 10% of 24 is 2.4, 20% will be 4.8. Now the quantity of milk will be 24 minus 4.8, which is 19.2 liters. Now I will have 19.2 liters of milk and the remaining water. The remaining is 10.8 liters water. Now I will have 19.2 liters milk. So here I will have 30 liters milk, here 24 liters milk, here I will have 19.2 liters milk and 10.8 liters water. Again from this I will be removing another 6 liters. So 6 liters is again nothing but 20%. So when I am removing 20%, so 10% is 1.92, 20% will be 3.84. So the quantity of milk will be 19.2 minus 3.84. So 19.2 minus 3.84. So quantity of milk that will be left is 15.36 liters of milk. So now I will have 15.36 liters of milk, and remaining among the 30 liters, 15.36 liters is milk, means how much water will be there? 30 minus 15.36, which is 14.64 liters water will be there. And this is what I will be doing. So the answer is 15.36 liters milk will remain after 3 such attempts, total of 3 such attempts. So first time I am removing 6 liters, then the same process is repeated 2 more times. So first when I remove 6 liters, there will be 24 liters. Again when I remove once again, which is 6 liters, I will have 19.2 liters. Again once more when I remove, I will have 15.36 liters. Next question is again about milk and water solution. A milk vendor has 2 cans of milk. The first one contains 25% water. 25% water, and the other contains 50% water. How much milk should he mix from each of the containers? Should he mix from each of the containers to get 12 liters such that the ratio of water to milk is 3:5. The question here is that there are two cans. So what is the quantity of 2 cans? They have not given, but the first can contains 25% water, second can contains 50% water. The second can contains 50% water. Now what I will be doing is that I will take some part of the first one, some part of the second one, and mix it together. So when I mix it together, finally I should get 12 liters such that in this 12 liters the milk and water are in ratio 3:5. So the water and milk are in ratio 3:5, which means the percentage of water here is 3 divided by 3 plus 5. So among 5 plus 3, 8 parts. So 5 plus 3 is 8. among 8 parts I have 3 parts of water. So I have water is to milk ratio is given. So water is to milk. So among 5 plus 3, among 8 parts, 3 parts is water. So 3 divided by 8, 3 by 8 into 100, which is nothing but 37.5 percentage I have water. 37.5 percentage I have water. So the first one contains 25% water, second one contains 50% water. Finally I need 37.5% water. So in what ratio I should mix means I should mix them in ratio. The difference here is 12.5, which is 1:1 ratio I should mix. However, they say that finally I will need 12 liters. Finally I will need 12 liters of the solution. If I need 12 liters of the solution, I have to add equal quantity of both the cans, equal quantity of milk from both the cans, which means I will have to add 6 liters from the first can and 6 liters from the second can. So the question here is that how much milk should he mix from each of the containers? So from each of the container he should mix 6 liters. From each of the containers he should mix 6 liters and 6 liters each. That will be the answer. A merchant has 1000 kilograms of sugar. Of which he sells a merchant has 1000 kgs of sugar, of which he sells some at 8% profit, and the rest at 18% profit. On whole, he gains 14%. On whole, he gains 14%. Find the quantity sold at 18% profit. Find the quantity sold at 18% profit. Here a merchant has 1000 kilogram of sugar. So he has 1000 kilograms of sugar. In this 1000 kilograms, some quantity he is selling at 8% profit. Remaining quantity he sells at 18% profit. And finally he can make 14% profit. So this again comes as a mixture and alligation problem. So I can use the alligation method to find the answer in which ratio they should be taken. So 18 and 14, the difference is 4. 8 and 14, difference is 6. In other words, 2:3 is the ratio. 2:3 ratio. Now I have 1000 grams. In this 1000 grams, some part I'll take and sell it at 8% profit, and the remaining I'll sell it at 18% profit. So 18% profit ka, so 3 by 5 into 1000. So 3 plus 2 is 5 parts. Among 5 parts, 3 parts I'll be selling at 18% profit. So total quantity that I'll be selling at 18% profit is 3 by 5 into 1000, which is nothing but 600 kilograms. This will be the answer. We'll be looking at one final problem in ratio and proportion. This final problem is a very commonly asked interview problem. So this is where most people will make mistake. The question goes like this: two solutions contain milk and water. Milk and water in ratio 2:3 and 4:1. Two solutions contain milk and water in ratio 2:3 and let's take it as 3:1. Two solutions contain milk and water in ratio 2:3 and 3:1. In what ratio both these solutions need to be mixed, so that the final solution contains milk and water in ratio. So there are two solutions that contain milk and water in ratio 2:3 and 3:1. In what ratio these solutions need to be mixed so that the final solution contains milk and water in ratio 3:2. 3:2. Now here, this is one type of question where most people will do it wrong. So here what you should do is that here the first one contains 2/5 milk and 3/5 water. So 2 plus 3 is 5. 2/5 of the first solution is milk and 3/5 is water. The second one has 3/4 milk and 1/4 water. The final solution I will need 3/5. So 2 plus 3. 3 plus 2 is 5. So 3/5 I will need milk and 2/5 I will need water. So here you apply alligation on any one element only. Either milk alone or water alone. The quantity of milk alone you take, apply alligation, or you take the quantity of water alone and still apply alligation. You will be getting the answer. Here I will do it on milk alone. So 2/5, 3/4, 3/5. So 2/5, 3/4, 3/5. So the difference between 2/5 and 3/5 is 1/5. Again 3/4 and 3/5, I will try to find the difference. So I will get the LCM as 20. So into 20 into 20 if I do. So I will get 15/20 here, and I will get 12/20. So 15/20 minus 12/20, which is I will get 3/20. So 3/20 is to 1/5. I get the ratio as 3/20 is to 1/5, or in other words I will multiply by 4 in the numerator and denominator here. So I will get 3/20 is to 4/20. Now 20 I can cancel and write the ratio as 3:4. So the ratio in which I should mix them both should be 3:4.